you required 86 kilojoule of energy. That is much, much higher. So it is not easy to break the carbon-carbon bond. Hence, it can form a long, long chains. Fine?
Okay.
So this was the catenation property of carbon. Now we are heading to the next. How do we represent organic compound? How to represent organic compound? So next topic is our representation of organic compound. So organic compound is represented in many forms. Okay. The very first form of representation is your structural representation. Structural representation.
The kilojoule per mole, isn't that the same like units as the like heat of fusion or heat of vaporization?
Yeah.
Oh,
Same. Okay. So structural representation, or we say it as dash formula. Okay. So what is the structural representation? Let's take an example. I'm taking an example of butane. So can you recall the formula for butane? What will be the chemical formula of butane? Butane belongs to which family? Alkane, alkene, or alkyne?
Alkane.
Okay, alkane. So what is the general formula for alkane? The general formula for alkane is CnH2n plus 2, right?
Yeah.
And in case of butane, what is the value of N? N, that is equals to 4. Now you substitute the value of N in the general formula and you will get the molecular formula.
Yeah. C4H10.
Yeah. C4H10, right? So how to represent C4H10 in a structural representation? So when you are told to draw the structural representation, you have to show each bond present in that compound. Okay. So if you are told to write the structural form of butane, so you have to show the each bond present in butane. Okay. So how many carbon atoms are there in butane? There are 4 carbon atoms. So we will draw all the 4 carbon atoms in a chain. 4 carbon atom. And just before we have studied that, the carbon shows tetravalency, means it forms 4 bonds. Now looking for this, let's say this is your carbon number 1. How many bonds have carbon number 1 formed as of now?
1 bond.
1. So it can form more 3 bonds. So with which atom it will be going to form more bonds?
Hydrogen.
So there will be 3 hydrogen atoms with which carbon will share its bond.
Yeah.
This carbon will share 2 bonds with hydrogen. This carbon will be sharing also 2 bonds with hydrogen.
Yeah.
This carbon will be sharing 3 bonds with hydrogen, right? So this is the structural representation, or we say the dash formula. Fine. Now the second form, the second way of representing organic compound is your condensed formula. Condensed representation or condensed formula. So condensed formula means, let's suppose, condensed as the name suggests, we are not going to show the bonds over here. Okay? Like in the first case, we have shown the bonds between carbon, carbon and hydrogen. Okay. But in form of condensed, condensed means we are not going to show any bond. All the atoms are in the condensed form. Like say, just an example I'm giving, like CH3, CH2, CH2, CH3.
Yeah.
So This is the molecular formula of butane. CH3, CH2, CH2, CH3. This is nothing but butane. So in here also, this is the formula of butane, but can you see any bonds over here between carbon or carbon and hydrogen?
No, it's represented different.
Okay, so this is the condensed form. Okay, and there is one more form that is partially condensed. Partially condensed. Partially condensed means we are only going to show the bond between carbon and carbon only, not carbon and hydrogen.
Okay.
So, like this. If I draw the partially condensed representation of butane, I can write it like this: CH3, single bond CH2, single bond CH2, single bond CH3. So this is your partially condensed formula. Now the next. Have you noted down?
Yeah.
Okay. Now the next is your third form of representation is your bond line representation. Very important. Bond line representation. Bond line representation. So how do we represent in form of bond line? Okay. So there are basic 2-3 points which must be kept in mind while drawing the bond line of any organic compound. The very first point that you must keep in mind that carbon and hydrogen atom are not shown in bond line formula, not shown in bond line representation. Means if you are asked to draw the bond line of any organic compound, that means you have to draw a structure in which carbon and hydrogen atoms are not seen directly.
Okay.
Okay. And the second point is, if any other atom other than carbon or hydrogen, okay, any other atom other than carbon and hydrogen are to be shown while drawing the bond line notation or bond line representation. And the atoms other than carbon and hydrogen in organic chemistry are said to be heteroatom. What are they said?
Heteroatom.
Heteroatom. So heteroatom must be shown while drawing the bond line representation. So this is your second point. The heteroatom is to be shown. Heteroatom is to be shown in bond line representation. So these are the two basic points that you must keep in mind.
Okay.
So what all are the heteroatoms like oxygen, sulfur, nitrogen, phosphorus? Means any atom other than carbon and hydrogen in organic chemistry are said to be heteroatom. Now let us take an example of butane again, C4H10. So if we are asked to draw the bond line representation of butane, how to represent butane in bond line form? So how many carbon are there? 4.
Yeah.
So we will draw it like this is the bond line representation of butane. Now the vertices of the line, suppose this point, point number 3, and this is your point number 4. These 4 points represent carbon. And in bond line notation, as I mentioned earlier, we do not show carbon and hydrogen. So how many hydrogens are over here?
10.
How many hydrogens are here at this carbon?
Add up at which carbon?
Carbon, this carbon. I'm
Ah,
talking about this carbon.
3.
3. Here, over here.
I oh yeah, here 2.
Okay, 2. So we are not showing hydrogen, but there are hydrogen.
Okay.
Otherwise the carbon could not satisfy its tetravalency. Okay.
Mhm.
Okay. Now I'm just giving some question from the NCRT. Just to solve it out. Okay. Write down the question. For each of the following compound, for each of the following compound, write condensed and also their bond line formula. Write condensed and also their bond line formula. So here is your question, right? So you have to write it in condensed, means you have to write it in partially condensed form and also in bond line notation.
Okay.
Write it down. I'm just writing the questions.
Oh, partially condensed. Okay. What does the bracketed CH3 mean?
The bracketed CH3 means that this CH3 is present on this carbon atom, the carbon atom just before it.
Okay.
Otherwise, the carbon atom just before it could not satisfy tetravalency. Like if I draw, the partially condensed of for the part A, so how we will write it? OH, now single bond CH2, single bond CH2, single bond CH2. Now there is single bond CH, right?
Yeah.
Okay. And this carbon, look at this carbon. Has it completed its tetravalency?
The last one? No,
Yeah, the last one, this one,
it hasn't. It only has 2
it
bonds.
has. It only forms 2 bonds. So now it will be forming the third bond with the CH3 next to it, which is it bracketed.
Yeah.
So now it will form third bond with this CH3. And the fourth bond, it will be forming with another CH, which you can see in the question. After bracketed CH3, there is a CH.
Hmm.
So it forms the fourth bond with CH. Now this CH now, it forms again one bond with CH3. There is the second bracketed CH3 group.
Hmm.
And at the last, this CH forms final bond with one more CH3 molecule.
Yeah.
So this is your partially condensed form. Okay. So now how we will represent in bond line notation? So just in bond line notation, we do not show carbon and hydrogen.
Yeah.
So how many carbon atoms are there in the straight chain? In a straight chain, you can see that how many carbon atoms are there?
6.
6 carbon atoms.
Yeah.
So just draw like this. 1, 2, 3, 4, 5, 6. Okay.
Hmm.
So now on carbon number 5 and carbon number 4, one CH3 group is already present.
In partial condensed form, you said that we only show the bonds between the carbon atoms, but you're showing like the bond between the OH and the CH2 groups. So like, why that?
Yeah, what you were saying?
You said that in the partial condensed form, you only
Hmm.
show bonds between the carbon atoms, but you're also showing a bond between the OH group and the CH2 group. So
No,
like,
it's in partially condensed form. You have to show the bond between the hetero atom and the carbon atom also.
okay,
There I was taking example of butane, which contains only carbon and hydrogen. So just I show the bond only between carbon and hydrogen. That's it. Okay, getting my point.
yeah,
So here OH is your here oxygen is your heteroatom, right?
yes,
So oxygen is your heteroatom. So we have to show the bond between heteroatom and the carbon atom also. Therefore, I showed the bond between OH and CH2.
okay,
Okay. Now we were drawing the bond line form of this, right?
yeah,
So there are 6 carbon atom, and if we come from the second last carbon atom contains one CH3 group.
hmm,
So this is your second last carbon atom.
yes,
So it will contain CH3. So how we will show CH3 in bond line? Just we will draw a single line. This is our CH3.
hmm,
Now
uh,
the third last carbon also contains one CH3. So
yeah,
we will just show CH3 by drawing a bond. This is our CH3. And now look for here the very first carbon atom CH2. Now CH2 is bonded to OH, right?
okay, yeah,
Okay. And we have studied before that in bond line we show the heteroatom. So we will be showing the OH. So where is the OH?
it's on the first
On the
carbon.
first carbon. So on the first carbon atom, OH is attached. So we will show it like this.
Okay,
So this is our bond line notation. For second part, have you drawn? For second question?
uh, 1 second. Second question. Isn't this already the partial condensed?
Yeah, it's already in partially condensed.
I need to do the bond one, the bond line.
Yeah.
3 carbon and Yeah, done.
Yeah, done. So
Hmm.
let's draw it out over here. So how many carbon atom in chain?
3.
Three carbon atom. Okay, fine. Three carbon atom. And the very first carbon atom is triply bonded with nitrogen over here.
Yeah.
So this is your carbon number one, and this carbon number one is triply bonded. So we will draw here triple bond, three bonds, triply bonded with nitrogen.
Oh, okay.
Okay. Now this is your carbon number two. Can you see it?
Yes.
So this is your carbon number two, and carbon number two is connected to OH group.
Yeah.
So we will draw a bond to OH. And thereafter there is another carbon atom that is triply bonded with nitrogen. So this
Yes.
is your third carbon atom, and just you have to draw triple bond with nitrogen. So this will become your triple bond with nitrogen. So this is your bond line notation for the second question.
Okay.
Okay. So you are clear about how to draw the bond line?
Yeah.
Okay, fine. So we will be moving ahead to the next topic, and that is our next topic is our hybridization. Hybridization. What is the meaning of hybridization? Okay. So hybridization is a topic which you will be studying in detail in chapter number 4, that is chemical bonding. Okay.
Yeah.
Just here we have to see the very basic of it, very small point of it. In the question, how the question will be asked to you that if there is certain organic compound, the question will ask what is the hybridization of each carbon atom. Like suppose in case of butane, there are four carbon atoms. So the question will ask what is the hybridization of all these four carbon atoms. So how to find out hybridization? So there is a formula for finding out hybridization. That is hybridization is equals to number of sigma bond plus number of lone pair. Okay, so this is the formula for finding out hybridization.
Okay.
Okay, now here there are two new things to you. One is sigma bond and one is lone pair. Do you know what is sigma bond?
No.
Okay, very simple. There are three types of bonds: single bond, double bond, triple bond, right?
Yeah.
When there is a single bond, the single bond itself is your sigma bond. Okay.
Okay.
In case of double bond, one bond is said sigma and the another one is said as pi. And in triple bond, one bond is sigma and the another two bonds are pi bonds.
Okay.
Okay. So in single bond, the bond is sigma. In double bond, one bond is sigma, another one is pi. And in case of triple bond, one bond is sigma and the another two bonds are pi bonds.
Okay.
And now the question comes, sir, what is lone pair of electron? So what do you mean by lone pair of electron?
Lone pairs is like it's referring to like the electrons, right?
Referring to electrons, but which types of electron? Are the
The
electrons?
that like the outer shell, which like uh with valence electrons almost.
The electrons which do not participate in formation of bonds are said to be
Okay.
lone pair of electrons. In the simple term, we say that the electron which do not participate in bonding are said to be lone pair of electron. Lone means it is alone. Like suppose in case of ammonia, nitrogen forms 3 bonds with hydrogen, right?
Yeah.
And nitrogen carries one lone pair of electrons. So this electron is said to be lone pair of electron. This is your lone pair of electron. Why? Because this pair of electron does not participate in bonding.
Okay.
So this is, so simple terms, the electron which do not participate in formation of bonds are said to be lone pair of electron. Okay. Now, if the value of hybridization, after calculating hybridization means after you add up number of sigma bond plus number of lone pair, if you will get 4, okay, if the value comes out to be 4, then the hybridization of that atom will be sp3.
Okay.
Means 4 means 1s and 3p. Total is 4, right?
Sorry.
1s and 3p together forms 4, right?
Yeah.
So if the hybridization comes out to be 4, it means it is sp3 hybridized. If the hybridization comes out to be 3, it is sp2, means 1s and 2p,
Okay.
right? If the hybridization comes out to be 2, it is sp, that is 1s and 1p, total 2. Okay.
Okay.
Now, these all are the hybridization. sp3, sp2, these all are hybridization on the basis of number. Now, the hybridization has certain geometry. Like, if suppose if the carbon atom in your organic compound is sp3 hybridized. So if the carbon atom is sp3 hybridized, its geometry will be tetrahedral. Just you have to remember this because we will be studying it in detail in chemical bonding, okay? If the hybridization comes out to be sp2, the geometry will be trigonal planar. If the hybridization comes out to be sp, the geometry will be linear. Okay. So just I will be just giving you the brief basis for geometry. What is tetrahedral geometry? How do we draw it? So tetrahedral geometry seems like this. Suppose this is your carbon atom, and if it is bonded to the other atom like this, so this is your tetrahedral geometry. Okay.
Yeah.
Trigonal planar means like this, like a triangle. Carbon is bonded to 3 other atoms like this. Okay. Now linear. Linear means straight. Carbon is bonded to 2 atoms, forming a bond angle of 180 degree. Okay. So these are the 3 geometries. Just I am giving you, there is no need to know the diagram for the geometry. We will be studying in chemical bonding. Just you have to know from here is, if the value comes out to be 4, the hybridization of atom will be sp3. If the value comes out to be 3, it will be sp2. And if it comes out to be 2, the hybridization will be sp. Okay.
Okay.
Okay. Now we are going to solve some questions from NCERT again. Write down the question related to hybridization. What is the type of hybridization? What is the
Yes.
type of hybridization of each of carbon? What is the type of hybridization of each of carbon? Of each carbon. Very first question. CH3Cl. Second question. CH3CN. Third part. CH3 CH double bond CH single bond CN. So here are the three questions. You have to find the hybridization of each carbon atom. Are you able to solve?
Yeah, I'm solving.
Have you done? Are you done with it?
Oh, sorry. I was mute. I'm done with A and B. I had a question about C.
Okay. Okay. Just complete it.
I think I'm done.
Okay. Now let's discuss it out, right?
Yeah.
So here is your CH3Cl. In the very first question, CH3Cl, how many carbon atoms are there?
One.
There is only one carbon atom. Okay, so what is the hybridization? So for knowing the hybridization, we must know that how many bonds this carbon atom has made, right?
Yeah.
So let's draw it out. Carbon, this carbon is bonded to 3 hydrogen and 1 chlorine, right?
Yes.
So we will draw 3 bonds with hydrogen, and this carbon forms its 4th bond with chlorine, right?
Hmm.
Now, how many sigma bond does it makes?
4.
4 sigma bond. 1, 2, 3, and 4, right?
Yeah.
Does this carbon atom carry any lone pair of electron? Can you see it?
No.
No, it does not carry any lone pair of electron. So it's what will be its hybridization? 4 plus 0,
sp3.
sp3. That comes out to be 4. That is your sp3 hybridized. So this carbon is your sp3 hybridized. Correct.
Okay.
Now moving on to the second question. In the second part of the question, how many carbon atoms are there?
2.
2 carbon atoms. Okay, fine. So this carbon atom is bonded with 3 hydrogen,
Yes.
and this carbon is bonded with Cn.
Hmm.
So this carbon is bonded with C, and this carbon is triply bonded with nitrogen, right?
Yes.
It is a triple bond. Don't forget here to put a single bond. There is a triple bond with nitrogen.
Yeah.
Okay. So now here we will get 2 hybridizations because there are 2 carbon atoms for each. So let's find out the hybridization for this carbon. What will be its hybridization?
sp3.
Okay, correct. It is sp3. And what will the hybridization of the carbon atom?
sp.
Sp. Very good. Why sp? Because this carbon atom forms 1 sigma with nitrogen and 1 sigma with another carbon.
Yeah.
That's it. And remaining other 2 bonds, that is the pi bond. And in calculation of hybridization, we do not include pi bond.
Okay.
Now the third part of the question. In third part of the question, what will be the hybridization for the first carbon atom?
sp3.
sp3, correct. Second one,
sp2.
sp2, correct. Third part,
sp2.
sp2, very good. And last,
sp.
sp, correct. Fine. Good. Now just do some more questions. HCONH2. E number. CS3 whole 2 CO. Now look for these questions. If you will see in this question, this carbon atom is bonded with hydrogen.
Yeah.
This carbon atom is bonded with oxygen, and also this carbon atom is bonded with nitrogen of NH2. Okay, so how we will represent it? Like this. There is a single bond between carbon and hydrogen.
Yes.
There will be single bond between carbon and NH2. Now, how many bonds can carbon form more?
2.
2. And these 2 bonds will be formed with which atom?
Oxygen.
Oxygen. So here the carbon forms double bond with oxygen. So there is one case you must always remember, कि except for OH, carbon always forms double bond with oxygen. Only in the case of OH, carbon will form single bond with oxygen. Okay?
Okay.
As we have seen while drawing the condensed formula, the very first question, do you remember? There we have shown the single bond between carbon and OH. Apart from this, carbon always forms double bond with oxygen. Will you remember this?
Yeah.
Okay. And as we will move ahead, we will go in more deep about this. Okay, now let's find out the hybridization. So what will be the hybridization of this carbon atom?
sp2.
sp2, correct? There are 3 sigma bond without any lone pair, so 3 plus 0, 3. Now, can you solve question number E?
Yeah, I'm doing it.
Okay, just do it. Can we discuss that question?
Yeah.
Okay, fine. Have you completed?
Yes.
Okay. So CH3 hold twice, then CO. Means this carbon is bonded with oxygen, right?
Yeah.
So it will forms double bond with oxygen.
Yes. And it's in
Now and
the
now this and now this
yes.
carbon will form two bonds with CH3
Yes.
because there are two CH3 molecules, so it will forms two bond with CH3. This is the structure you have drawn.
Yeah.
Okay. Now let's
Uh,
find
what,
out the hybridization.
what was the name of that? The CO thing. I think it had a name. What was it? Like the CO group that's in
Oh,
the
CO,
middle of
that is carbonyl group.
what? Carbon? What?
Carbonyl. Carbonyl
Carbon.
group.
Okay. Yeah, I remember a little bit.
Carbonyl. Carbonyl group.
Okay.
It is a functional group. You have heard about ketone.
Yeah. Yeah. Okay.
Okay.
Wait.
So this is the functional group of ketone, C double bond.
o- Okay.
Okay. So what is the hybridization of this carbon?
Which one? The outside? This one? Yeah.
The very first carbon.
sp3,
sp3. The second one,
sp2.
sp2, and then it is sp3. Okay. So you are done with the hybridization part also.
Okay.
Easily you are going to find out the hybridization of the atoms.
Yeah.
Just you have to apply the formula and just you have to see that which type of hybridization is present. Okay, so today I will end our class here. Okay,
Okay.
so just a basic recall what we have studied. What all we have studied, can you just recall it?
We studied about the different structures, like the partial condensed, the condensed, uh, and uh, the line, the bond line
Okay, so the very
representation.
first thing, yeah, the very first thing which we studied, that we studied which organic compound was formed in laboratory first,
Yeah.
and how it was formed. We have seen the chemical reaction.
Mm.
And after that, we have seen why maximum organic compounds contain carbon atoms only. So we have seen the two reasons behind it. And the two reasons, what were they? The very first reason was that the carbon atom shows tetravalency, and the second reason was the carbon atom shows catenation properties.
Yeah.
And thereafter, we have seen that catenation property is not only shown by carbon atom, it is also shown by other atoms too. But other atoms are not involved in organic compounds. What was the reason behind this?
Because the bond between carbon atoms is stronger.
Yeah, because carbon-carbon bond is stronger than in case of any other atoms. So it will forms a long chain. Therefore, it will shows maximum catenation property. And after that, as you were saying, we studied about how to represent organic compound. The very first we have seen is structural representation, where we show all the bonds present in the organic compound. Oh, acha. He's connected, sir. Now he disconnected. Okay, okay. So you're
Yeah.
back, right? Okay.
Yes.
Okay, just we were going about what we have discussed, and there at last I will give you certain questions for your homework from the topics we have covered today. Okay. So I was telling that we have studied about structural representation, and after that we have seen condensed formula, and after that followed by bond line notation. And in bond line notation, we have studied that we do not represent carbon and hydrogen in bond line form. Okay,
Yeah.
we only show the heteroatom present in the organic compound.
Okay.
And after that, we have seen how to draw the bond line, and at the last, we have seen how to calculate hybridization, how to find out hybridization of carbon atoms in an organic compound.
Hmm.
Okay, so this is for today, and now just I will give you some homework on the basis of the topics covered in today's class. Okay, just you solve them out.
Okay.
Okay, write down the questions. Write the question. Write the state of hybridization. Write the state of hybridization. Write the state of hybridization of carbon. Write the state of hybridization of carbon in following compounds. Write the state of hybridization of carbon in following compounds and geometry of each molecule and geometry of each molecule and geometry of each molecule. Okay,
Yeah.
so here are your three question. Means in this question you have to find out the hybridization, and also you have to mention the geometry.
Okay.
So if it comes out to be sp3, then it is tetrahedral. If it comes out to
Yes.
be
Yes. Yes.
sp2, it is trigonal planar.
Yeah.
And if it comes out to be sp, it is linear. Okay,
Yes.
now write down the next question. Write the bond line notation. Write the bond line notation. Write the bond line notation. The first question, CH3, CH double bond, C, C2H5, CH2, CHOH, CH3. Have you noted down the questions?
I'm writing down the third one.
Okay.
Okay.
Oh, you have noted down?
Yeah.
Okay. Now see in the third question, I'm just giving you an idea about the third question. The bond line notation one. This third question.
Okay.
So look at this structure. The
Yeah.
cyclic structure. Are you looking
Mm.
at it?
Yes.
This cyclic structure is already in the bond line form, isn't it?
Yeah.
So you do not have to convert it in bond line form. It is already in bond line form. Just you have to convert this part in bond line form.
Okay.
Okay, so you have to keep in mind. And now the next part of the thing is, you are looking for a C2H5. We have C2H5.
Yeah.
Okay, this C2H5 is nothing but CH3 single bond CH2. This C2H5 can also be written as CH3 single bond CH2. Okay.
Okay.
Okay, so this is what I was trying to say. Now it's your part of homework that you do, and if you will find any sort of doubt, we will discuss it in the next class.
Okay.
Okay. So any doubt from today's class?
So, which chapter was this?
This
Like,
chapter was General Organic Chemistry. According to NCRT, this was your second chapter, the volume 2.
second chapter.
Volume 2.
Second chapter of volume 2. Okay.
Volume 2. Or you can remember is that the first chapter of Organic Chemistry
Okay.
of class 11th. And the name of this chapter is Some Basic Principle and Techniques.
Some basic principles and techniques.
Yeah. The name of this chapter is Some Basic Principle and Technique
Okay.
of Organic Chemistry.
Okay.
Organic Chemistry, Some Basic Principle and Technique.
Okay.
And this is your second chapter in volume 2.
Hmm.
And in terms of unit, this is your unit 8. And in terms of unit, this is your unit 8. And in the form of chapter, this is chapter 2 of volume 2. Okay?
Okay.
Fine. Okay, then thank you for listening to me and attending the class sincerely.
Okay. Thank you.
Okay, thank you.
Thank you. Bye, sir.